Section 1 of Chapter 1 focuses on analyzing categorical data. So we're looking only at our categorical variables, remembering that those are the variables where we're grouping things or putting the individuals into categories based on a similar characteristic. So when we're working with categorical data, it's easiest to first organize our information into a table and then use the information from that table to create the graphical display. The goal is to really look at that graphical display to try to learn what the data is telling us. So when we create these tables, there are two types of tables that we work with. The first, the frequency table, and the second, the relative frequency table. In a frequency table, it's going to list the categories and the number of individuals in each category. Okay. A relative frequency table, on the other hand, lists the categories again, but instead of listing the number of individuals in each category, it's going to list the percent of all individuals in each category. Okay, and we're going to look at some examples of this in class and potentially in these notes. However, if you wanted to see an example, you can find an example of a frequency and a relative frequency table on page 8 of your text. So once we have our information organized into a table, then what we're going to work on is making a graphical display for that data. So for our categorical variables, there are really only two displays to choose from: the bar graph or the bar chart, and a pie chart or a pie graph. So oftentimes the bar graph is the easiest to use. It's easier to make and it's easier to read. And essentially the bar graph just represents each category as a bar. So each bar is a category, and then the bar's height gives us the frequency or the percent of the individuals. Okay, and these bar graphs are good and they're easy to use simply because any set of data can be represented with a bar graph. The pie chart, on the other hand, is a little bit more complicated simply because you have to have the percentages of the whole. So this is going to represent the category as a percent of the whole. And it's often more complicated to create because in order to make an accurate pie chart, we would need to be worried about the size of the angles in relation to the percentage that they represent. So typically we work more often with the bar charts because they're much more flexible and they give us a good picture of as to what it is that's happening. So take some time and think about some of the benefits and disadvantages to each of these graphs. For example, like I said, the pie chart is complicated to create, whereas the bar chart is easier to create. Can you think of any other advantages or disadvantages of using each of these graphs? A third type of graph that's often used when we talk about categorical data is what's called the pictograph. And while pictographs are pretty to look at, they're often misleading and they give us the wrong impression as to what the data is actually trying to tell us. So this is an example of a pictograph from the textbook where what we're looking at is a display of the number of buyers for each of these previous computer types out of a group or survey of 500 iMac buyers. So if you notice in this image, the actual height of the computer is appropriate. It matches the values that we're getting from the table. However, the area that this computer covers is significantly larger than the area that's covered by the other two computers. So our eye is drawn to that, and we are under the impression that it is actually much larger of a percentage than what it is in reality. It is a very big percentage. However, the area that it's covering is misleading. You'll notice that the difference between the two smaller ones looks significant when in reality the difference in the percentages is only 5%. Okay? We also need to be careful with bar charts and make sure that our bar charts are appropriately displaying the data. So for example, on the right, you'll notice that this starts at 10, which gives us a misleading or misguided idea as to what this set of data is telling us. So I wouldn't use this one either. This first bar chart is going to be the best option because it doesn't cause a problem with the area, and it's measured equally along the side. So let's go ahead and look at an example here. We have some information. It says Miss Brown opened a bag of peanut M&Ms and collected the following information. So we have the list of the colors as well as the count. Our variable here is going to be the color of those peanut M&Ms. Who are the individuals that we're studying here? So the individuals that we're studying are those peanut M&Ms. And like we said, the variable that we're studying is the color. And of course, color is a categorical variable. So from here, we want to create a relative frequency table from the given information. So in order to create a relative frequency table, I need the total count or the total number of M&Ms in that bag. And then I'm going to take the count for each color and divide it by the total. All right, so I did a little behind the scenes magic, totaled up all my M&Ms, and I calculated 210 of these peanut M&Ms. So for the percent of each, I took the count. So let's say for red, I took the count of 40 and divided that by 210, which gave me approximately 19%. Okay, so here are my percentages in a relative frequency table. And if I want to check myself, the best thing to do is to go ahead and add these together and make sure that we are at a total of 1 or close to 1. We may have a little bit of a rounding error since I did have to round some of these. So let's see where we're at. And we were at 0.99. So that's my rounding error from where I had to round a few of these up and down. And we're okay. As long as we're about 0.99, 1, or 1.01, we're okay. Okay? So I wouldn't stress too much that it's not exactly 1. From here, I want to create some sort of display for the distribution of the peanut M&Ms. Now, because we have percentages, we might be tempted to try to create a pie chart, but that's going to be kind of difficult. So what I'm going to do is I'm just going to create a relative frequency bar chart. And so on my bar chart, there are a few things that I absolutely have to remember. I have to remember to draw my axes. All right. Okay. I want to label the axis. So this is the color and this is the percentage. I want to make sure that I create an even scale along my axis. So I need to go from about 0.07 to 0.24. So I think I'm going to go, excuse me, we'll do 0.05, 0.10, 0.15, 0.20, and 0.25. And that should encompass everybody. Then I'm going to draw my bars. We'll do red, orange, yellow, brown, green, and then blue. If you have the space, I would definitely write it out. I'm just a little tight on my space here. So for red, we're at 19% or 0.19. So I'm going to draw my bar to about 0.19. Please excuse my drawing on here. I'm pretty awful. And then we have 0.13. My yellow is 0.15. Brown is 0.07. Green, we're going to go up to 21. And then blue is going to go up to 24. Okay. Now we should always try to create bars that are the same width. Sometimes I know it's difficult to do, especially on the iPad, but we're going to try our best to make bars that are of equal width or as close as possible to equal width to avoid that issue with the area like we saw with the pictograph. Okay. Question D here is actually kind of redundant. I had added other questions before and I didn't realize to take this one off. It's asking just what % of the peanut M&Ms are red, and that's just what we found in the red group, which is 0.19. If you have any questions on creating this, we could have also done here a different graph and done color and frequency from the first table, and we would have found that our graphs were very similar in their shape. So oftentimes we want to take information for two variables and we want to make some sort of comparison. So in order to do that, we can use what's called a two-way table, and there are different kinds of distributions we can use and a different kind of graph we can talk about in order to determine whether or not there's a relationship or an association between two variables that are categorical in nature. All right, so we would use a two-way table to describe, two categorical variables. Okay, and we see tables like this all the time. There's an example in your textbook with gender and opinion on page 12 if you wanted to get a look at that. Page 12 in your textbook. And essentially what we do is we have one variable that's along the rows and a second variable that's along the columns. And then throughout the center of the table, you have values that tell us how many individuals fell into each of these categories together. And then on the edges, you have your totals for each of these independent variables or separate variables. I apologize. Okay. Now, part of what we can do with this information in a two-way table is calculate what's called a marginal distribution. And so the marginal distribution gives us the distribution of just one variable in a two-way table. Okay, and this information is found along the margins of the table. All right, the other type of distribution we could be looking at is what's called a conditional distribution. And so for a conditional distribution, what we're looking at is how one variable is distributed based on meeting some condition of the other. So we're still looking at a distribution of one variable, but it happens to be based on a condition of the second variable. So if I'm comparing someone's opinion to their gender, a conditional distribution could look at the opinions, but only for one gender. For example, the opinions of only females or the opinions of only males. Okay, so that's a conditional distribution. It has to meet some condition of that second variable. And then the last definition we have here is an association. So association typically means some sort of relationship, being related in some way or another. And we will say that there's an association between two variables if knowing the value of one variable helps to predict the value of the second variable. So for example, there would be an association between the gender and their opinion if knowing that they were a female helps me to predict their opinion on the matter. And so we either say that there is an association or that there is no association. All right, and then just one other thing to be mindful of here is that we should remember that strong association does not mean causation. It does not lead to one thing causing another. And the relationship can be influenced by other variables. Okay, and now we'll take a minute and we'll look at an example. So looking at this first question, the question reads, what % of the college students were female? So this is a display of college students, and they're separated by their sex or their gender, and then also an age group, each of those being categories, okay? So it says, what % of the college students were female? So in this case, I'm focused only on all of the college students, which is everybody in this table, and I want to know the % that are female. So the total for the females is down at the bottom of the female column. So the % of females is 9321 divided by 16,639. Okay, and you can change that into a decimal and then calculate the % if you would like. Part B says, what % of the female college students are 18 to 24? So now instead of looking at all of the college students, I'm focused only on one group. That one group that I'm focused on, the female college students, that's my condition. So I want to know, out of this group of female students, what % of those students are 18 to 24? So I'm going to take my 18 to 24 within the female column, and I'm going to divide that by the total females, which is 9321. And we'll change that, calculate the decimal there. The next question says, what % of 18 to 24-year-olds are female? So now I'm looking at this the other way around. My group that I'm conditioning on, or the group that I'm focused on here, is the 18 to 24-year-olds. So that's this whole group right here. And I want to know from that group what % are female. So I'm focused on the 5,668 out of the 18 to 24-year-olds, which is 10,365. Okay. D asks me for the distribution of age among the female students. So how are the females divided, basically? So the females in our group from 15 to 17, we have 89, out of all the females. In our group from 18 to 24, we know that we have 5, 6, 6, 8 out of all the females. In our group of 25 to 34, we have 1, 9, 0, 4 out of all the females. And then our 35 and over, we have 1, 6, 6, 0 out of all the females. So this is a conditional distribution. It's showing me how the ages are divided based on the condition of being a female college student. Okay, so that's conditional distribution. Now the question also asks me for the marginal distribution of the student's sex. So the marginal distribution is dealing only with one variable, in this case, the sex. So we have our females, which are 9321 out of the 16,639. And then the males, which are 7317 out of that same 16,639. Okay, and that's a marginal distribution. It focuses on only one variable. All right, so this question is asking, how is the sex or the gender divided for each age group? So for each age group, we want to look and see how they're divided based on the gender. So for the age group from 15 to 17, okay, for our females, there are 89 out of 150, and our males are 61 out of 150. For our group from 18 to 24, our females are 5, 6, 6, 8 out of 10, 365. And our males are 4, 6, 9, 7 out of 10, 365. Okay, I'm going to do the other two off to the side, and I'm going to change these into percentages, and then we'll talk about the next question. All right, so here's our information on the conditional distribution of the sex. So how is the sex divided based on the age group? So I went ahead and for each age group took the female and the male, separated them within the group, and divided to come up with these values. Now, the last question here is asking if there's an association between the age group and the sex of the college student. So one of the things you can do is create or construct what's called a segmented bar chart in order to make these decisions. So I'll show you now how to make the segmented bar chart, and then we'll talk about how to make that decision. So let's scoot this up a little bit. Essentially, a segmented bar chart is kind of like creating a pie chart, except you're using a bar. So I'm going to construct two axes, and I'm going to take my vertical axis and I'm going to make this the percent. And now we're going to ensure that this vertical axis ends up at 100%. Okay, so we've got our 10, 20, 30, 40, 50, 60, 70, 80, 90, and 100. And so for each of these age groups, we're going to construct a bar that totals 100%. Again, excuse my drawing, pretty awful. And we want these bars to be as close to uniform as possible. We want them all about the same size. So this first bar is my 17 to 24. The next bar is my 20. Whoa, I apologize. That is incorrect. This first bar is 15 to 17. Then we have 18 to 24. 25 to 34 and our 35 plus. And what we're going to do is we're going to take these bars and we're going to divide them to match the percentages we calculated above. So for 15 to 17, 59% or about 0.59 is female. The male is the other part. For 18 to 24, we're at about 55 female. So the male makes up the rest. 25 to 34 is at about 54, so relatively close. And then 35 plus is about 63. So female and male. Now this is our segmented bar chart. And this is used to help us decide whether or not we feel there's an association between these two variables. So we said, if there is an association, that means knowing the value of one variable helps you to predict a value of another. So in this case, knowing that someone was between 15 and 17 helps us to predict whether they are female or a male. So if knowing something about the age helps us to predict whether they are female or male, we should see significant differences in our bars. So if the bars are similar to each other, then that would tell me that there's really not an association between the two. It doesn't appear that knowing one thing helps me to predict the other. So I would say that in this case, most of these bars are similar. So it would appear to me that there is no association between sex and age group as the percentages are very similar. Okay. And now what we have here at the end is just a few things to keep in mind. I'm not going to go over them. You can look over them yourself. And should you have any questions, see me. And we will take care of it for you. We are going to go over some of this in class, just not in this detail. Okay? Thanks.